Hello. In this video, I'm going to explain the math in the movie Tyson's Run. I'll show the scene here in a second where his mother is homeschooling him, helping him with this algebra problem. It turns out it's not algebra, it's calculus, but I'll explain the math in Tyson's Run and show you what it is. So let me press play and let's watch.
I'm sorry, Tyson, I'm lost. And how am I supposed to teach you something I don't even understand myself?
Shoot. There's this movie Tyson's Run's on Netflix. I was hoping this pause wouldn't have all these icons on it. But anyways, this is the problem they're working on. This is called the complex exponential function. So we have e to the iy, so this is the exponential function. Usually we think of this as we're putting in a real number, like e to the 10th power or something like that, but you can also put in an imaginary number there. And then the weird thing is when you put in an imaginary number, it becomes periodic. Usually we think of exponential growth as something that keeps going up and up and up and up. That's for real numbers. But for imaginary numbers, it's periodic, it's oscillatory. So we have all these terms in there. You have to remember the I is the imaginary number, the square root of -1. And so the high-level summary is this is using Taylor's theorem, which is actually really interesting. Taylor's theorem says that if you know all the information about a function at a single point, if you know the function's value and all its derivatives at a single point, then you can know the function's value everywhere, which is kind of crazy. It's a pretty cool result. So he says he wants to go to high school where he can learn algebra there, but this is not algebra, this is calculus, because Taylor's theorem is calculus because it involves taking the derivative of the function, all the derivatives, the first derivative, second derivative, third derivative, and so on, at a single point. So because of, when we stick in the imaginary number I here, I squared is -1, I cubed is I to the 4th is I. So this weird thing happens that the odd powers of I remain as I, and the even powers, the odd powers remain imaginary, and the even powers become real numbers, because I squared is -1, which is a real number, and I to the 4th is 1, which is a real number. So this cool thing happens, and you get the cosine of y. Cosine is an even function. They call it an even function because the powers of its Taylor series are only even, like 2 and 4 and 6 and so on. And then the imaginary part are the odd powers remain imaginary. So e to the iy equals cosine x plus I sine of y. And cosine and sine are periodic functions. So that's this really cool algebraic cancellation miracle happens, and you end up with that. And towards the end of the movie, there's a scene of him writing on the blackboard where he sort of does the one-line proof of what I just explained, and he writes, equals cosine y plus I sine of y. So the things to remember is that this is Taylor's expansion of a complex exponential. It's not algebra, it's calculus. So don't feel bad if you don't know what this is, because it's calculus. I don't know why they call it algebra in the film. And yeah, it's a beautiful result where you get this cancellation miracle of even powers of I staying real, so you get the cosine function, and odd powers of I remaining, so you get the sine function, so you get I times the sine function. So that's what's going on in the math problem of Tyson's Run. It's a pretty cool movie. I liked watching it. My wife and I watched it over the weekend, where this kid, there's this African world champion marathon runner that comes to their town, and the kid has autism, and he becomes friends with this African world champion runner, and then the kid ends up running a marathon in his hometown. And so it's a sweet movie. I'd recommend watching it. And now you know everything about Tyson's Run math problem. Thank you very much.